Okay, so here's a situation that's happening at software companies right now. You're a developer. You sit down, open your laptop, and there's a pull request in your queue. The thing is, an AI wrote it. Not your teammate, an AI agent. But there's a problem that you cannot see. Statistically, about 1 every 12 PRs like this are going to fail on some weird edge case in production, often at 3 a.m. in the morning on a Saturday. The code just does the wrong thing and nobody notices for a while. That's the world that we are shipping software in now. Now you probably already know that AI made writing code really cheap. That's not really news. But something else has also happened that most engineering teams haven't really sat with yet. Reviewing the code that AI writes. That has gotten really expensive. Figuring out if the code should even exist, expensive again. Catching what's wrong in something that looks right, really expensive. And here's the uncomfortable part. These skills have always mattered. They've always been the hard part of being a good engineer. AI didn't just suddenly make them important. It just made it really obvious who has them and who's been faking it. So in today's video, I want to walk through 5 questions. 1. Are these skills actually going to matter long term, or am I just doing the usual AI panic routine? 2. If they do matter, why? What's the real reason they'll still be valuable even when AI gets a lot better than it is today? 3. If you're early in your career, watching this in 2026, what should you actually do? 4. What does any of this mean if you're an Indian engineer? Because there's a specific angle here that I want to talk about. And 5, is this video basically a long way of telling junior developers that they're cooked? Because if that's what I'm saying, I should just say it. Alright, let's jump right into it. Let me show you the data, because there's a lot of it. LinearB looked at pull requests with AI-generated code. They sit in review 4.6 times longer than human-written ones. Review time has gone up 441%. Bugs per PR went up 54%. The code is taking forever to be reviewed. And when it does ship, it has more bugs. CodeRabbit ran their numbers across 470 organizations. Reviewers are spending 91% more time on AI-generated code, but they're also catching 75% more logic errors in it, which tells you that the second look is doing the real work, not writing the code itself. Now, Sonar put out their State of AI Code report for 2026. They surveyed over 1,000 developers. About 42% of code written today is AI generated, and 96% of developers say that they don't fully trust it. There's even an Anthropic study with a smaller sample of 52 people that found a 17% drop in how well developers comprehended code when AI was helping them write it. Adi Osmani has a name for what's happening here. He calls it comprehension debt. You're shipping code you don't fully understand, and that debt slowly builds up over time. There are 5 different sources from 5 different angles, and they all land in the same place. The bottleneck is real. It's measurable and it's happening right now. Now, the cleanest way I've heard this described comes from Anders Hellsberg. If you don't know him, he's the person that created TypeScript. He also created C#. He said, our craft is going from writing the code to reviewing the code. And that's exactly it. That's the shift. And it's coming from someone who's written more code than almost anyone alive. Now, I want to be fair here. Before we go any further, you should be a little skeptical. Is this really an AI problem? Or have these skills always been important and AI just exposed something that was already there? But the answer to that completely changes what you should do about it. Let me ask you to forget about AI for about 2 minutes. What does it actually take to build software that runs in production and does not fall over? 3 things really. You need someone that can catch bugs before customers do. That's code review. You need someone who can decide whether you should even build the thing in the first place. That's judgment. And you need someone who understands how a change in one part of the system affects everything else. That's system thinking. Now, none of this is new. What AI really changed is not how important these skills are, but how visible they have become. Think about it this way. When writing code was slow, review was kind of baked in. A senior engineer typing out a function was also reviewing it as he went. The 2 activities were fairly tangled together. You couldn't really separate them. Now, you can. The AI generates the code in seconds, and then a human has to review it. That review step is suddenly its own thing, sitting there as its own line item in the process. And because it's now the slowest, hardest part of the work, everyone can see it for what it is. The bottleneck didn't appear because of AI, it became impossible to ignore. So yes, these skills matter. They always did. But the next question is the real one. Are they actually safe? Like from 10 years from now, when AI gets a lot better than it is today, will these skills still hold up? I think they will. And here's exactly why. 3 things survive even if AI gets dramatically better at writing code. The first one is accountability. If something breaks at production at 3 a.m. on a Saturday, you are the one getting the call. You can't outsource that to a model. The second one is context. The AI knows your code base only through whatever you fed into the prompt. That's pretty much it. You know about the meetings 3 quarters ago where the PM said, we're never supporting this edge case. You know about that one architectural decision the previous team made that doesn't appear in any documentation, but explains why everything is the way it is. All of that context lives in your head. The AI cannot get to it, and it never really will, unless you somehow upload your career into a prompt, which is not really a thing. The third one is judgment, about whether the code should even exist. If you were to try a thought experiment, pretend that tomorrow morning AI becomes perfect at writing syntactically correct, test-passing code, like flawless code, and every PR is just pristine. Do those 3 things I just talked about magically go away? Of course not. Which brings us to the part that actually matters in your life. What do you really do about it? What do you actually do today, tomorrow, this week, this year to develop these skills? Especially if you don't have a senior engineer hovering over you, teaching you how. Now, I'm going to break this down into 3 different stages, depending on where you are in your career. Each stage will have 4 things that you can start doing immediately. Let's start with stage 1. Now, this is for people who are early in their career, somewhere between 0 and 2 years. Your job at this stage is to build a foundation. And the foundation is being able to recognize what good code looks like. Because here's the truth. You cannot review code if you don't know what good code looks like in the first place. 4 moves for this stage. First one is to read more code than you write. Pay attention to the choices the authors made and ask yourself why they did it this way and not the other way. The second is to do what I'd call open source archaeology. Pick a feature in a project that you admire, Postgres, Redis, the Linux kernel scheduler, whatever you find interesting, and then trace its history. Look at the original commit, read the bug reports that came after, see how it got refactored over time. The third is to review yourself ruthlessly. Before any PR you create goes out, especially if AI helped you write it, read your own diff line by line. Find your own mistakes before someone else does. I know it'll feel really tedious, because it is, but it's the easiest possible training ground for becoming a reviewer, because the target is your own work. And the fourth one is what I like to call the lattice check, named after the interview format. For any code that you ship, ask yourself one simple question. Could I write this in a coding interview with no AI assistant in 4 minutes? If the answer is no, you have just shipped code that you don't fully understand. Okay, now stage 2, which is for mid-career engineers, somewhere between 3 to 7 years. You have got a foundation, or you should. Now your daily work has shifted. You're reviewing way more code than you write. 4 moves for you would start off by treating AI pull requests differently from human ones. AI code has a specific failure mode, which is false fluency. It reads correctly even when it's wrong. It looks really confident. The structure is fine, but there's something just off. And you have to train yourself to give it a second, more skeptical look every single time. Second, learn the specific patterns where AI tends to fail. There's a small set. It hallucinates APIs that don't actually exist. It misses test cases for edge conditions because it couldn't enumerate them. It writes confidently the wrong logic that compiles fine but does the wrong thing. Once you know these patterns, you can scan for them very quickly. And third, this one comes from Arpit Bhayani, who calls it asking opposites. When you're reviewing a line of code, ask yourself what the counter argument is. Why would someone make the opposite choice? And if you can't even articulate a real case for the opposite, then you did not actually review the code. You just nodded along. Now, stage 3. This is for senior engineers with 8 or more years of experience. Your personal reviewing is fluent at this point, so the leverage moves somewhere else. Your output is no longer your code. Your output is your team's ability to review quality. For someone like you, the 4 moves starts off with setting standards. Write them down, put them in a document, defend them in code reviews. What does your team consider acceptable AI-generated code? What do you never merge? What requires a second pair of eyes? Do not leave this as tribal knowledge. Make it written. Number 2, mentor reviewers. You used to ship features. Now you ship reviewers. The time you spend teaching a junior how to spot AI failure patterns will pay off 10 times more in the same time spent reviewing PRs yourself. Third, build the systems that make good review easy. PR templates that ask the right questions, automated checks that catch common patterns, hooks that flag when AI-generated code is missing tests. This kind of infrastructure is your real product at this stage. And finally, and this is the one that matters most for being promoted, your team's review quality is your output. A senior engineer who lifts the team review culture by even 20% has shipped more value than a senior engineer who shipped a feature themselves. Now, I know that some of you are thinking, especially if you're a junior, hang on. Stage 1 assumes that I have time to sit and read code. But AI has removed that whole phase of writing from scratch that used to teach engineers judgment in the first place, right? So how is it even possible anymore? I've started calling this the fresher paradox. The AI helps you ship, but it skips the experience that would have made you a real engineer. Now, the stage 1 moves I just gave you, they're an attempt to fix this. Reading more code than you write replaces the old loop of seniors reading your code. Open source archaeology replaces the apprenticeship with the entire history of engineering decisions. Self-review replaces the senior catching your mistakes. The lattice check forces you to actually own what you ship. Is this as good as having a senior in the room mentoring you? Honestly, no, nothing really is, but it's the closest thing we have when a senior isn't there. And it works if you actually put in the work. Now, I want to talk about something specific to only Indian engineers, because there's a real opportunity here that I don't think enough people are talking about. 2 specific things about engineering in India that you should know about. Indian CS programs, with very few exceptions, are lead code first and project light. Code review is basically absent from the curriculum. You graduate having never seriously reviewed someone else's production code, and nobody has ever seriously reviewed yours. You don't just get the reps in. And number 2, the major Indian SI firms have historically been thin on review culture. Junior code tends to get merged with very little feedback. Senior engineers are spending most of their time on project management, not on careful code review. So you don't pick it up either. But here's the thing, both of those gaps are actually the opportunity. If you are an Indian engineer who deliberately runs the playbook I just laid out, you read more code than you write. You build the second look habit for AI code. You start reviewing your own work before sending it out. And then you are building a muscle that almost nobody in your cohort is building. And we're in a global hiring market where this muscle, that's the new bottleneck. Companies are desperate for engineers who can review well. So if you become unusually good at it, that compounds very fast. Indian engineers can absolutely win in the AI era, but only if you notice where the game has shifted. The game has shifted from writing fast to reviewing well. That's the new ground. And it's wide open right now. Another question I keep getting from students, especially from DSML or CS programs, is my degree still useful in 2026? And the answer is yes, but only if you layer all of this on top of it. Your degree teaches you how systems work, theoretically. The playbook teaches you the practical judgment that makes you employable. You need both. One without the other is not enough. Which leaves one last question to answer. If you actually do all of this, what are you exactly turning into? Here's what the whole playbook is building towards. And I want to name it directly. You are trying to become an engineer whose code gets trusted by the time it's shipped. When you open a pull request, the reviewer's first reaction shouldn't be, let me check every line carefully because I'm not really sure what's here. It should be, this person's code has already been thought through. The edge cases are handled, the tests are there, and it fits into the system properly. The output of all of this work is trust. And once you have trust, speed comes naturally. Trusted code merges faster, it ships sooner, it breaks less, and the benefits stack on top of the other over time, until you are the person on the team who consistently gets things done well. The engineer who develops real judgment is the one who's going to do well in this AI era. They were always going to do well, honestly. AI just made it more obvious. So here's the conclusion. The skills you need to develop, which is reviewing, judgment, and systems thinking, those have been fundamentals forever. They are not going away. They survive even the most optimistic version of where AI is heading. There's a concrete playbook you can run starting today, depending on where you are in your career. If you're an Indian engineer, you have an unusual opportunity here because most of your peers are not building this muscle deliberately. Now, the question I want to leave you with is the one that I unfortunately can't answer for you. Am I that engineer? The one whose code earns trust before anyone reviews it? You are the only person who can really answer that one. If this video is useful, Please like the video, share it with someone that might find it useful, and subscribe to our channel.